All right, if you're making API calls to large language models, I've got some news for you. You're paying a hidden tax on every single request. But today, we're going to talk about a way to stop paying it. We're diving into a data format called TOON, and it's specifically designed to slash your LLM bill by getting rid of all the useless overhead in JSON.
So, here's the game plan. First, we're going to expose this syntactic tax that's bloating your JSON payloads. Then we'll introduce TOON as the perfect loophole to get around it and dig into its secret weapon, the header. We'll even look at some benchmarks that show how this makes prompts not just smaller, but actually smarter. And finally, we'll tackle the big one. Do you have to completely re-architect your whole system to even use this thing?
Let's kick things off with a problem you might not even know you have. It's a hidden cost that's embedded in the very structure of JSON, a format we all use, every single day.
And here's the problem in a nutshell. Every single character in your API call costs you money. Doesn't matter if it's OpenAI, Anthropic, Google, you pay for every byte. And what's wild is that a huge chunk of a standard JSON payload isn't your actual data, it's just fluff.
We're calling this the syntactic tax. It's all those curly braces, the brackets, the quotes, the commas, everything the format requires. Yeah, they're essential for structure, but they inflate your token count without adding any new information. You're literally paying for punctuation in every API call.
Okay, so what if there was a way to just avoid this tax? Well, that's where TOON comes in. Think of it as a tax loophole, but one that's designed from the ground up specifically for your LLM prompts.
TOON stands for Token-Oriented Object Notation. Now, its purpose isn't to replace the entire JSON data model we all know and love. Instead, it's meant to be a lossless, drop-in representation of your JSON, but one that's hyper-optimized for LLM input.
And this slide just captures the difference perfectly. On the left, you've got your standard JSON array. Just look at all that repetition, ID, name, distance km, over and over and over again. That is the syntactic tax in action. Now look to the right. That's the TOON version. It's the exact same data, but all that redundant key repetition, it's gone. It's just clean, dense, and way more efficient.
So here's the bottom line. The benchmarks show that TOON uses almost 40% fewer tokens to represent the exact same data as JSON. For anyone paying an LLM bill, that's a nearly 40% cost reduction on your data payloads right there. And let's be honest, that is not a trivial amount of money.
So, how does TOON actually pull this off? How does it get these savings? Well, let's take a look at the cleverest part of its whole design.
The big idea is actually super simple, but it's incredibly powerful. For an array of similar objects, why on earth are we repeating the same keys over and over again? It's just wasteful.
TOON implements this with something it calls tabular arrays. And honestly, it works just like a CSV header. You define the structure and the field names once, right at the top. After that, it's just the raw values, line by line. All that key repetition just vanishes.
I'll admit, when you first look at it, it can seem like a weird mix of Python and an Excel spreadsheet. But that structure, while it might look a little different to us, is a feature, not a bug, especially for a machine that's trying to parse it. But of course, saving tokens is completely meaningless if the LLM can't understand the data. So let's look at the benchmarks and see how TOON actually performs when it comes to model comprehension.
Now this is what's really interesting. TOON isn't just smaller, it actually improves accuracy. In data retrieval tests across 4 major models, TOON hit a nearly 74% success rate. That's compared to just under 70% for standard JSON. So it's not just cheaper, it's better.
So why is it more accurate? Well, it really comes down to TOON's built-in guardrails. Things like explicit array lengths and those field headers give the model a really rigid schema to follow. For an LLM, this is so much easier to parse correctly than some complex, deeply nested JSON object with a ton of closing brackets and braces that it could easily miss or just hallucinate.
Now, as a back-end engineer, you're probably thinking about the practical side of this. A new format sounds great in a lab, but what about in production, right? So let's just address the biggest question head-on. Is this new format really worth the headache of re-architecting systems that are all built around JSON? I mean, our databases, our services, our logs, they all speak JSON.
The answer from the creators is a clear and resounding no. You do not break your pipelines. TOON isn't meant to be a replacement for JSON everywhere in your stack. It's a specialized tool for a very specific job.
The intended workflow is actually really simple and non-disruptive. You keep using JSON for your database, your internal services, all your APIs. Then, at the very last moment, at the prompt layer, right before you send the data to the LLM, you perform one single encoding step. That's it.
This approach makes adopting it a low-risk, high-reward optimization, not some massive, scary migration project. You get all the benefits of token efficiency without having to tear down and rebuild your existing infrastructure.
And that really leaves us with a final thought. For any application sending structured data to LLMs, TOON presents a seriously compelling case for big cost savings and better reliability, all with minimal effort to implement. So the question isn't really if you should consider it, but why wouldn't you?